Hello viewers, welcome to my channel Science and Technology. In today's show, Rocket Monday, we're going to talk about NASA's moon base 3-phase plan. So let's dive deep into it. Now, this is the plan. Now, let it be very clear. There is a lot of depth to the plan, but you should not need to focus on that. The main thing that you have to take away is that this is the first action plan after Apollo. This is Apollo's action plan. Everything was clear. What we're going to do, Apollo 4, 5, Apollo 5, Apollo 7, Apollo 8, Apollo 9, Apollo 10, Apollo 11. Everything was brick by brick. We're going to test this part. We're going to test this part. Everything was methodically done. And there was a clarity of purpose. Now you have to understand, after space shuttle went kaboom, there was no clarity. Bush on paper came up with a good idea. It's like, okay, we're going to take the parts of the same space shuttle and make a system, Constellation. And Constellation was a huge thing, meaning the idea was not to make something that is small. The idea was they're going to use the solid booster as a rocket for small payloads and use the liquid tank as a big rocket. So, and they were planning for making something magnificent, like the hope and dreams of the project was huge. Bush leaves the office, then Obama comes in. Obama smokes something bad and he's like, you know, what's the point of going to the moon? Give me something different. So NASA pivots and creates a brain damage idea known as asteroid redirect mission. Basically, go to asteroid, bring it here. Why? Ask Obama. And again, that created the worst side effect system where it was like, hey, project cannot be delivered because again the original plan from Bush era was too magnificent and too huge, and again it was delayed, but all these redirection wasted so much time that basically Obama at the last end was like, okay, cancel the whole damn thing. And when he cancelled it, Senate was like, nah, you can't cancel it. We cannot allow people to lose jobs and design a new rocket and have a better thing. No. You have to maintain the job. So use the same part. So basically, they took the Constellation, reworked it, classified it SLS. So everything is a mess. Why the heck there is a LOPG? There is no reason. It was a plan that was necessary for asteroid redirect. It's why it went to the moon, nobody knows. It was just like, but ISS is expiring. At that point, we could do this. It's like there was no reason, no rhyme. But this is the first time after Apollo where it is like, this is what we're gonna do. So the idea is land, step one. Step 2, what is the end goal? End goal is stay hereafter, meaning it should become normal thing how ISS is. Whereas like people are always in ISS. You don't think about it. The end, it's there. It's done, sorted, good, go home. And again, what about ISS? Hopefully, target of NASA is that sooner or later there will be more and more. Axiom is already working on it. Other companies are already working on it. There will be enough private space stations that they will not need to work on it. They will rent it from private players, like how right now NASA rents Falcon 9 from SpaceX. Same way. So basically, they've sorted out the technology. Technology is available for public. Build it, and we're gonna rent it from you. So that's how they're gonna deal with that. And no magic jump and if this then that. Very simple, clear steps. That's the most amazing part of it. It's like, you know, Artemis II, which they did not wanted, but what else you could do it. It was a like, you know, operation around the moon. So capsule testing is done. Okay, cool. There is no use of it because there is no lander sorted. That's why I said there was no plan. There was no method to madness. It was just madness. So Artemis 3 comes back to low Earth orbit and it's like, okay, we're just gonna figure out the lunar landing system. And core reason is they have to build regular missions to build up competency. Everything is designed such a way that you're gonna have at least 1 mission a year, if not 2 missions per year. That's why you'll see there is like, you know, Artemis 3 and 4, like they are so close to each other. The idea is it should become normal and routine. And how the heck they're gonna solve the SLS problem? Do not touch SLS anymore. Meaning whatever exists in SLS, the end. No more block 2, block 2B, none of that. Throw all of that away. No more tower upgrades, throw all of that away. So competency is the key part, and this time the biggest difference between Apollo era and now is government and private partnership. And private partnership is a bit different here. This is not like, okay, NASA designs something and private players have to build it. No, this is like, we want this ability, figure out how to do it. Up to you. So that's the difference. And on top of that, the biggest turbocharger is competition, meaning they will not rely on one supplier, no matter who that is. Does not matter whether it's ULA, does not matter it's Boeing, does not matter it's SpaceX, does not matter it's a Blue Origin. It has to be multi-redundant system. So that's a biggest difference. Like if you night and day difference is that, where like everything is fundamentally backupped. Where it's like, if this works, awesome. If does not work, we should have something else. So tech will be built gradually. Everything, like they are using moon lunar eclipse mission protocols, so they can slowly, brick by brick, test every single small piece of technology they need to make sure a permanent habitat. Be mindful, Apollo was a dhappa mission, where it's like, it was not like go and stay. So go and stay, that requires way too much technology. So that will be done on a smaller, low cost, low risk variant. Oh, sorry, low cost, high risk. There is no guarantee that it will work. But again, they are expecting that by the time they are on their 5th or 6th mission, landing on lunar moon on low cost landers would be child's play, hopefully. And again, things can happen. So they will build up gradually, and aim is to go to moon the early phases every 6 months at start, and after that slowly stretch that stay period. Like, first time they will stay for 5 days, then they will stay for 1 month, then they will stay for one whole lunar night. That would be a big deal. Then 2 days on the moon, so to say, day night, and then slowly brick by brick, months, and then year. The idea is permanence, meaning they should have a base there that they just, it's a thing. Rockets come in, astronaut comes out, returning astronaut takes the rocket back home. Should be normal thing. So that's the plan, very clear. And I have to say, like, this guy ironically might have lucked out because of China, because China was so close. It is sorted that China will land in 2030s. It may be 31, it may be 35, but it will happen because China is very sorted. Their plan is something like this: A, B, C, D, E, F, G, H. So he has the advantage that now the politics is not interfering. We want to land before on moon, the end. How do you do that? Figure it out. So they are not fighting him anymore. Now, Artemis 3. Artemis 2 is going on when I'm making this video, or if you are watching this video as a member. Artemis 3 is supposed to happen in 2027. Hopefully. And SLS rocket is ready. Let that be very clear. It is ready, meaning the capsules and all that. Yeah, those are physically built. They are ready. They're ready. Bro, we're ready to go. So that's the good part. Now, there's supposed to be 2 puppies ready at that point. One is SpaceX Starship. If it's ready, they're gonna dock it. And Blue Origin lunar lander. Now, Blue Origin, blue lander they have, is supposed to be landing on moon right now. Like as in April 2026, but they have candidates because it will be now the test article in Artemis 3. I think this gave Bezos company a much bigger advantage than you realize. Now, can Jeff Bezos try an attempt directly on Artemis 3? Of course he can. And given the track record of the rocket, which again, hopefully mid-April they will have the 3rd launch. If that 3rd launch of the rocket goes well, New Shepard New Glenn happens normally, the probability that this will be able to successfully launch, successfully dock with Orion would be much higher. And be mindful, this design is far closer to be delivered in order to land on moon before 2030. Starship cannot do that. Like, no. Like, that's the Elon weird, it's like, 2024, we're gonna land on the moon. No. If you are smoking something so bad where you're like, hey, what if this 2-stage rocket tries to do 3-stage work? You will come up with dumb ideas like, hey, what if we refuel it? It's like, what's the benefit of refueling 13 times, 15 times, 20 times? I've never gotten an absolute number like this is how much it is. Oh, they also need a refueling craft. By the way, this topology is also designed with refueling, but one refueling because it's a 3rd stage. So fundamentally, the priority is docking in 2027 in low Earth orbit. And NASA has already made calls with SpaceX and Blue Origin. And again, that's why Blue Origin shifted the launch schedule. So, although that does speak ill of them, because if they were planning to launch this anyway, they should have built another one. So, I think they're balancing it out. It's like, do we push it or do we make this better? Because again, there will be humans in Orion at that point in time. So, this cannot be just like, oops. So that is the human interaction is the main thing. Can we trust humans and differently built systems to work together while there are humans inside safely? And if something goes bad, low Earth orbit to return is much easier than a return from the moon. So that's the Artemis 3 part of it. Now, the dreams are good, but you need some tools to make those dreams. One is LTVs, lunar terrain vehicles, basically rovers, lunar rovers. And be mindful, the contracts for that was already going on. But again, if you did not know about this, that's the whole point. There was no clarity who was building this, why they were building this, what was the budget orientation. It's just like, yeah, we have to go to the moon, but we are also building LOPG as a lunar gateway and all that. So who is funding for it? Why is that? But they have clarified it. It's like, it could be, let me figure, this is early draft, so this could change. They want double duty. Now, I do not know whether they mean two different rovers or a rover that can pull double duty, as in crewed system, which is astronauts on it, and remote, as in somebody either in the habitats can drive it or somebody on Earth. Driving from Earth would be a bit messy because latency would be there for give or take 1.2 seconds. So latency would be there, but it's manageable. It's like playing a game in a laggy system. It's manageable. And the weight category is 500 kg. Now again, if they want remote, it's not that difficult. Most of the things are drive by wire anyway, so it's not that difficult, and I don't think they're gonna put AI into it. So it should be doable. Remote driving should be doable on the same rover without having too much mass penalty. So that is there, and speed is 10 km/h. This is specifically chosen that it will not self-destruct if it hits something, and it should be manageable. Another reason why you do not want to go YOLO is that dust that it will, kick up in the air will, not air, kick up in the lunar low gravity well, it will stay there for too long. So fundamentally, that's why you do not want to scoop up too much dirt. And the slope, because they are expecting to traverse a lot of craters, they want to go into the crater and come out of the crater safely. That requires them to, like, I think this is Mach 1 requirement, 20-degree slope, which again, how lunar craters are, that's good enough, but they might need to push a bit more, get Audi Quattro people to build it to have a higher gradient dodgeability, but let's see. And it should be able to handle shadow of 150 hours. Now, like, why would it be in shadow? Because again, if it does not have nuclear heater or anything of that nature, basically non-nuclear system, it's very unlikely that it's going to work in the lunar night, full night. So the idea is they're going to charge it from the day and drive it. But what if they are going inside the crater and it's shadowed region? This should not freeze up. So 150 hours is that point, meaning let's just say astronaut parked it and it's in the shadow region, it should still remain functional. So that's why this number is not 350. 350 would be required for a complete night exposure. This is just like, oh, you went into shadow for a few hours and now your rover is froze up. That should not happen. But again, I'm reasonably sure, and Japanese are also contributing. They are building a rover that is literally habitat on wheels that should be able to just, push through a full lunar night. So this is LTVs, half-ton puppies that are lightweight, agile, and maybe pulling double duty. Now we are talking about drones, which is weird because the name of the drone is Moonfall. A very weird movie. So it's a very weird approach for surveillance, because I'm like, can't you just have rovers? A lot of rovers, cheaper. So because there is no atmosphere. Mars has an atmosphere, very thin atmosphere, but does have atmosphere. Benefit of that is you can fly helicopters there. This puppy has proven that quite effectively. So now they are imagining plans where they only have helicopters. That's how effective this was. Moon does not give you that luxury. So the idea is they're going to have small probes, almost landers, and the lander will have basically rocket engine that can turn on and off rapidly, and it can give burns of 150 seconds. So basically, whoosh, something like that. So that should allow them to go as high as 1 kilometer and land from there. And again, they do not want to go very high because landing will require stronger legs if they do that. So they're balancing it out, and the idea is to cover around 50 kilometers. Now, will they have too much technology into this? No. The idea is this is supposed to be cheap, but training instrument, meaning they're going to figure out how this, almost like what this is, what we call technology demonstration mission. And the idea is they should be able to scout things and maybe double use this. For example, land it somewhere and this will become a remote antenna for them. Something like that. So it's more of a proof of concept that can we trust the rocket systems and all that. And again, there is a problem with that rocket thrust, dust. So that's why I'm finding it odd. It's like Mars, it makes sense. There is atmosphere, there is stronger gravity, so dust is not that big of a, here it is a big issue. So everybody going whoosh, whoosh, whoosh is like, unwise. Now we come to the main daddy, which is the final thing they have to do, is nuclear power. Because again, if you have power, you can tame everything. Does not matter which planet or basically moon you're dealing with, you can figure it out if you have power. So they're starting with the small puppy, which is RHU. radioisotropic heater unit. So the idea is that you have a radioactive material that is actively decaying and you put it in a shielding. Why? The shielding job here is not to actually protect anything, because again, it's an unmanned system. The idea is, instead of having high energy particle radiations or high energy photon radiation like gammas and all that, which can cause bit flips and damage to your computer equipment, basically the shielding that they are using, graphite basically, it's going to absorb those photons, and basically high energy particles, they're going to absorb it and release it as lot of low energy photons, as in 100 gamma rays went in, thousands of infrared photons come out. So it's like a transformer. So it will supposed to make it so what you call inert, that electronics next to it will be like, bro, me good, not like cut, bit flipping, corrupting and all that. So that's why it does need shielding. It has 1 watt of power. Now, is that enough? Yes and no. We have used this for many deep space mission because unless you have RTG and you are relying on solar panel, the body temperature will slowly start to go very critically low once you start to go very far away, like Mars, Jupiter, Saturn, Uranus. Once you start to go to that level, it will start to freeze. So having this allows you to maintain your temperature without spending energy. It's just there. Like, you do not have to think about it. It's like, we good, we got this, it's there. So that's the whole point. And that will allow, basically this RHUs will allow cheaper drones, cheaper units, cheaper rovers to cross that 360 hours mark. So where they're like, bro, we good, we can just like turn us off, or we're gonna shut down anyway. And then we're gonna just like, our battery bank will remain good enough temperature. Most other things can handle low temperature. It's the battery that does not like it. Battery will not start back up if you froze it to like, minus 100 degrees Celsius. So battery is like, bro, we're gonna keep you at, let's just say, minus 10 degrees Celsius. Because be mindful, once your temperature starts to cool down, first it takes time. Second, the lower the temperature becomes, the lower the flux becomes. So you cool down even slowly. So 1 watt at those sort of contexts is more than enough. Because if you are exposed to the lunar sunlight, you heat up a lot. So after that heat up, cooling down will take time. And you only have to make sure that the last, last 2 days before the sunrise happens, that last 2 days, this would be enough. That is for small puppies. Big puppies will require RTGs. And if you know any about Apollo, Apollo also carried RTGs. So RTGs is gonna solve the night. Basically, if you have RTG, this allows you to hibernate the night. This allows you to work at night. For example, if you took Mars rovers, you drop them on the moon, they will work. That's not an issue. They will just work without any hassle because they have RTGs. RTGs not only give them heat, but it also gives them electricity. So we are talking about hundreds of watts of electrical energy. How many watts? That depends on the design and mission profile, but you are looking at anything at least above 100 watt. So that will allow us to solve, meaning if we have 10-20 rovers, these rovers can work 24/7/365 for a few years without any issue. So that's the thing. And technology is tested. Again, Apollo tested it, Voyager tested it. We good, we got this. And enough for core functionality, meaning if there is a human habitat, RTG should have enough oomph to keep it functional. Whereas like, hey, maybe we should be able to run your life support, maybe freezing won't be an issue. That will not be an issue. So it can make sure that temperature never becomes an issue. Core criticals functionality can be maintained. That would be the point of RTGs. And then slowly jump into this puppy. This will allow us to colonize the moon. So this is NASA's ancient project that is cursed, known as kilowatt reactor. I cannot tell you like how many times this project was started and closed. Like, it's hilarious. Like, they started this project and they turned it off. They started this project and they turned it off. They are starting it again. Let's see what happens this time. So the idea is, if you have a reactor, now you do not talking in hundreds of watts, you're talking kilowatts, even few kilowatts. Few kilowatts, 24/7 until 10 years. That's a lot of power. How much power? That is so much power that you can start to colonize the moon, because this will eliminate all your solar power requirement for the habitat. Now you're gonna put a bonkers amount of solar power and use that for your industry. What industry? Take a lot of solar power, turn that into energy, be it maser energy, be it infrared laser energy, whatever have you, and then start melting regolith. Start making bricks. That is the first requirement of energy there. Once they can figure out which method works, does the microwave melting works, does the infrared laser works, or something else, whatever have you, once they have figured out how to melt it and how does it work, how does it solidify, cools, all of that, they will start to make pads that will consume energy. So the idea would be habitats work 24/7, but During daytime, solar panel allows you to work effectively the industrial part. So industrial will almost like daytime. Oh, industry only opens up during daytime, and nighttime everybody sleeps. So people will work. And again, could you have battery? Some amount of battery would be required, and I'm reasonably sure nuclear reactor could divert some power from here and there to do some work. At least for testing it can be done, but bulk work will be done on solar, because again, why would you risk taking hundreds of this if solar panel are exponentially cheaper and exponentially safer? So people are like, hey, this to get the base rolling and solar to do the heavy lifting. Mixing both of them together gives you best of everything. So that's the aim, and that's what I said, like everything had clear path. This is what they're gonna do. Like they're starting with RHU, then they're jumping to RTG, then they're jumping to kilowatt reactor. Everything is thought out and it can actually work. This you can buy and utilize the many NASA mission. This was used on the moon, so it's sorted. This is the cursed one, but again, this is like 2035 or something. So we good, we got this. So this was my presentation on what the hell NASA is gonna do for 3-phase to the moon. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me your disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.